So we're going to start a unit on graphing trig functions. Let's start with the two basic trig functions, sine and cosine. In order to graph these functions, I'm going to figure out a couple of ordered pairs for these graphs, and I'm going to start with the quadrantal angles. So that means I'm going to evaluate sine at 0, 90, 180, 270, and 360. Then I'm going to do the same for cosine. I'm going to evaluate cosine at 0, 90, 180, 270, and 360. The only thing is, when you're graphing trig functions, you're working in radian measure for your x values. So I'm going to express the quadrantal angles in radian measure. 0 degrees is 0 radians, and f of 0, let's figure out what that is. In order to evaluate sine, we have to go back to the unit circle and say we're working with 0 degrees. This ordered pair is, this ordered pair is 1, 0, and the y-coordinate there is 0. Therefore, the sine of 0 is 0. 90 degrees in radian measure is pi over 2, and f of pi over 2, let's go back to the unit circle and see what the y value there is. The y value there, ordered pair, is 0, 1. Y value is 1, so the sine of 90 is 1. Okay, 180 degrees in radian measure is pi. F of pi is, let's go back to the unit circle. Here's pi. That's not rotating the way I want it to, so hold on 1 second. And here is pi radians, which is 180 degrees. The ordered pair there, -1, 0, and the y value there is 0. So f of pi is 0. 270 degrees in radian measure is f of 3 pi over 2. Just remember how to convert to radians, multiplying by pi over 180. Let's figure out the y value there. The y value there is, again, it's not rotating the way I want. There's 270 degrees. The y value there is -1. Therefore, f of 3 pi over 2 is -1. And finally, 2 pi is 360 degrees in radian measure. And at 2 pi, the y value there is 0. Therefore, f of 2 pi is 0. So now we have 1, 2, 3, 4, 5 ordered pairs that we can plot. Let's plot the graph of sine. So, we're going to set up our x-axis in radian measure, just like we have instead of parentheses here. These are going to be all of our x values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. When you're graphing trig functions, separate each 90 degrees by 4 boxes. So 1, 2, 3, 4, pi over 2. 1, 2, 3, 4, pi. 1, 2, 3, 4, 3 pi over 2. 1, 2, 3, 4, 2 pi. Okay, so those are all of our x values. Our y values, you can see, range, no pun intended, between -1 and 1. So the lowest the graph reaches is -1. The highest the graph reaches is 1, with zeros in between off there. Notice the pattern: 0, 1, 0, -1. 0, 1, 0, -1. 0, 1, 0, 1, 0, -1. The pattern is called harmonic. So let's plot those ordered pairs. The highest the y value is 1. The lowest the y value is -1. And now we're just going to plot all the ordered pairs that we know. F of 0 is 0. So at 0 degrees, or 0 radians I should say, the y value is 0. F of pi over 2 is 1. So at pi over 2 radians, sine is 1. Pi over 2 radians goes up to 1. Again, I'm just plotting ordered pairs here. F of pi is 0. So at pi radians, sine is 0. At 3 pi over 2 radians, -1. 3 pi over 2, down to -1. And at 2 pi radians, sine is 0. So at 2 pi, sine is 0. So here's the graph. Let's connect it. And there's the graph of y equals sine x. Notice it's not sharp, it's a curve. Do not make points. Make these things look like curves. Now let's focus on the graph of cosine. Let's evaluate all of the quadrantal angles for cosine. So what we want is g of 0, g of pi over 2, g of pi, g of 3 pi over 2, and g of 2 pi. Again, we're going to go back to the unit circle for this. Not necessary. If you just know that this is 0, 90, 180, 270, 360, you could just think about what the x coordinates are there. We'll show that. Working with 0 degrees first, 0 radians I should say. The x value there is 1. So, g of 0 is 1. Now we're looking at pi over 2 radians, which is 90 degrees. 90 degrees, the x value there is 0. So just to show you what we're going to get for our x values, we're starting with 0 radians, then pi over 2 radians, then pi radians, 3 pi over 2 radians, and 2 pi radians. So we're going to have 1, 0, negative 1, 0, 1. 0, negative 1, 0, 1. 0, negative 1, 0, 1. Yeah, it's a pattern. That's because as we go across the x-axis, all we're doing is rotating around and around and around and around. So the first x value is 1, the second x value is 0, the next x value is negative 1, the next x value is 0, and the next x value after that is 1. You can go back to unit circle to verify this information. So let's plot all of these ordered pairs to see what the graph of cosine looks like. Again, we're going to separate each 90 degrees by 4 boxes. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, pi. 1, 2, 3, 4, 3 pi over 2. 1, 2, 3, 4, 2 pi. Every 4 boxes is another 90 degrees expressed in radian measure. Make sure you express it in radians. So now we'll look for the maximum and minimum values to see what to put on our y-axis. And the maximum value here is 1, and the minimum value here is negative 1, which means the y values range, pun intended that time, from negative 1 to 1. So that's what we'll put on our y-axis, from negative 1 to 1. Okay, let's plot these ordered pairs. G of 0, 1. So, when x equals 0, then cosine equals 1. There's our first ordered pair. G of pi over 2 is 0. So when x is pi over 2, cosine 0 on the y-axis. G of pi is negative 1. So when x is pi, we're down at negative 1. And then our next y value is 0, and our last y value is 1. Once you get the first couple, you should have the pattern. 1, 0, negative 1, 0, 1. And we're only plotting at quadrantal angles here. So now again, just like the graph of cosine, like the graph of sine, make it look smooth. Here's the graph of cosine. So you'll see that these two graphs look different. Here's the graph of sine, and here's the graph of cosine. Now, if we continue graphing this, you can see that they're very close to the same thing. Let's continue graphing. Say 1, 2, 3, 4. That would be 4 pi over 2, so 5 pi over 2. 1, 2, 3, 4. 3 pi. If we want to continue graphing, we know the pattern here. 1, 0, negative 1. These graphs do not end, they keep going. So if you see here, if we were to start the x-axis there, or here, that would change the graph, the shape of the graph. If the y-axis were here, for example, that's the graph of sine, which means the graph of sine and cosine are the same. They're just different by a horizontal translation. Okay, but for now, what we learned is that y equals sine x looks like this, and that looks like a snake. Y equals cosine x looks like this, and that looks like a cup. So just to draw a distinction between the two graphs, they're very similar in the fact that they're harmonic and the values repeat, but they're different because they start at different values. The sine value is starting on the line, and the cosine value is starting in the middle. Okay, so sine snake, sine on the line, cosine cup starts in the middle.